and welcome to our fourth and final review video of our 2024 URTeC papers. My name is Bob Aylesworth, and I'm the Business Development Manager here at RevoChem. This video will focus on a really cool project that we did with Ovintiv in the Uinta Basin. The title of this paper is Analysis of Zonal Interference through Integrated Stimulation and Drainage Diagnostic Measurements in the Uinta Basin, including microseismic, Crosswell strain, offset pressure fracture measurements, and geochemical fingerprinting of produced hydrocarbons. This paper was actually presented as a team presentation by the folks at Ovintiv. If you want to learn more, check out the actual URTeC paper, which is URTeC 4043150. So this study focuses on the Uinta Basin and integrates multiple diagnostic measurements to help understand the interaction between mechanical stratigraphy, fracture geometry, and effective drainage for wells landed in different benches, including the Upper Castle Peak, the Uteland Butte, and the Upper Wasatch. In the center of the cube development was a vertical observation well with permanent fiber, isolated external casing pressure gauges, and a vertical geophone array to map hydraulic fracture growth. We also performed high-resolution geochemical analysis in order to quantify the production contribution from different formations through time. So the key objective here was really to evaluate the stacking and spacing. They wanted to understand a few key aspects, including the hydraulic fracture geometry, and they did that by looking at Crosswell strain, microseismic, and pressure. Looking at effective geometry by understanding the pressure changes during initial and production shut-ins, and then measuring the drainage heights by using the geochemical fingerprinting of the produced oils. We're going to be focusing here on wells landed in the Upper Castle Peak, the Uteland Butte, and the Upper Wasatch. So from our standpoint, we looked at 31 different produced oils from 7 different wells collected over a 2-year period. Now typically each well had 4 samples collected through time, but in this graphic we're only going to focus on 3 distinct different timestamps. So as you can see here, one well was landed in the Upper Castle Peak, and samples were taken on day 17, day 199, and day 801. We also looked at 3 wells landed in the Uteland Butte and 3 in the Upper Wasatch, with similar time-lapse monitoring of like day 17, day 199, and day 775 or 801, depending on the well. So these produced oils were then compared back to a geochemical fingerprint baseline, which was created from cuttings, ranging between a 10 and 15-foot vertical spacing. This allowed us to create a very high-resolution drainage height and quantitative zonal contribution. You'll notice that in general, drainage is predominantly coming from within the target formation. We saw no overlap between Upper Castle Peak and Upper Wasatch wells. Uteland Butte wells did show drainage into the uppermost portion of the Upper Wasatch, but this seemed to be correlated. This seemed to correlate more with spacing and pressure, which I'll actually show in a second. But in general, the drainage heights and zonal contributions are quite stable throughout the entire monitored length of time. So one interesting observation is actually related to well spacing. So here I'm going to show some microseismic data as well as the geochemical production allocation data. So the standard larger well spacing showed less frac overlap in microseismic, and the production allocation indicated that Uteland Butte wells drained from primarily within the Uteland Butte, but did have some Upper Wasatch contribution, whereas the Upper Wasatch wells were isolated to within the Upper Wasatch. However, the closer spaced wells, they showed significant frac overlap between the Upper Wasatch and Uteland Butte. However, the production allocation from the Uteland Butte wells still showed very little contribution from the Upper Wasatch wells, which is likely due to pressure compartmentalization. Interestingly, the last sample here, it actually does show an increased Upper Wasatch contribution, similar to what we saw in the larger spacing development. However, this sample, it was noted that this was taken during a temporary Upper Wasatch well shut-in. The integration of all these data sets greatly improved the conceptual model of interplay between main hydrocarbon-bearing zones and how to land and space these wells. The key conclusions from this project were that there was excellent agreement with all the fracture diagnostics along with the producing geometries. The fractures grew through the Uteland Butte and Upper Wasatch with minor production interference, but the geochemical allocation profiling suggested very little long-term resource sharing. And the Upper Castle Peak wells tended to grow down to the Lower Castle Peak, and Uteland Butte wells tended to grow up into the Lower Castle Peak later in stage, which suggests a possible resource sharing. However, again, the geochemical profiling indicated fairly well constrained drainage. Ovintiv also noted that this comprehensive suite of diagnostics early on in the development provides a really important baseline to further optimize your developments. Understanding the mechanical stratigraphic controls on hydraulic fracture growth and reservoir drainage is absolutely key to making informed decisions on wine rack configurations for optimal reservoir drainage. So I really hope that you found this summary interesting. As always, please check out that URTeC paper for more details, especially on some of the other diagnostics that I didn't touch on. And if you want to learn any more about what RevoChem is able to do to help you better understand your reservoir drainage, please don't hesitate to reach out. Thank you.